In this lesson, we're going to take two shorter topics and combine it to make one lesson here. So first we're going to start off with sketching lines. Throughout A-level, you'll be doing lots of sketching of graphs. Later, you'll look at things like quadratics, exponentials, and various other graphs. But today, we're just going to focus on sketching lines. Now, when we sketch a graph, we should always, if we can, show where it crosses the x and the y-axis. When we're sketching lines, they're pretty much always going to cross the x and the y-axis, unless, of course, they are parallel to the x-axis or parallel to the y-axis. Two really important things to note here, and that's how do we find out where it crosses the x-axis, how do we find out where it crosses the y-axis. Now if we start off with the x-axis, what we should notice is that the value of the y-coordinate for every single point on that x-axis is just 0. So if you want to find out where a graph crosses the x-axis, we just sub in y equals 0. And likewise, if we want to find out where a graph crosses the y-axis, all the x-coordinates have a value of 0, so we just substitute in x equals 0. You can also think of it as another way of describing the x-axis is it simply is just the equation y equals 0, and the equation for the y-axis is just x equals 0. What we're going to do then is look at some examples from page 12. Now when you're sketching a graph, you haven't got to draw out every single, plot every single point, or obviously it's a line, it's going to have infinite points, but you don't have to do a scale or anything like that. The key thing is you get the right shape of the graph, which is easy here, it's just going to be a line, and that we also get where it crosses the x-axis and where it crosses the y-axis. So we've got this equation here, there's no need to rearrange it. We'll start off by seeing where it crosses the y-axis, and it crosses the y-axis when x equals 0. So we substitute x equals 0 into there and rearrange, and we get y equals 3. So that's where it's going to cross the y-axis. We then want to find out where it's going to cross the x-axis. That happens when y equals 0. So substitute y equals 0 into your equation, rearrange, and we get x equals -6. So now I'm going to sketch the graph, and I'm going to show you how it's really not a lengthy process when we're sketching. We just need to draw some axes here, and then just draw our line. Yes, it is better if we use a ruler, but the fact is here, I'm showing the key points, okay? It's just a sketch, it hasn't got to be perfect. So I just need to make sure I've got those key points, where it crosses the x-axis, and also where it crosses the y-axis. Looking at our next example, I'm just going to go straight ahead and show you the solution. So I just do the same thing again. I don't need to rearrange it. I'm just going to simply substitute in x equals 0 to find out where it crosses the y-axis. So here it crosses at y equals 1 over 7. We definitely just want to use 1 over 7 here. Don't put what the decimal is here because it's like 0.142857. We don't want to write that on our sketch, so just leave it as a seventh, leave it as the fraction. And then we also want to find out where it crosses the x-axis, so substitute in there y equals 0, and then draw your sketch. So that was a very quick part on sketching lines. The next bit, what we're going to do, and this bit will be a slightly longer part of the video, is parallel and perpendicular lines. So if two lines are parallel, so let's just do a little sketch here. They both have the same gradient, okay? We know that parallel lines, they're not going to meet, okay? But also they have the same gradient. So if you say that the gradient of your first line, we call that M1, and the gradient of the second line, we call that M2, they are going to have the same value. Now two lines are perpendicular if they look something like this. Okay, you've got two lines here and they're going to meet at right angles to one another. Okay, in this case, if you multiply the two gradients of both lines, you should get -1 if they are perpendicular. So what this means is if a line has a gradient m, so if you call this, so if this first line here has a gradient of m, the perpendicular line will have a gradient of minus 1 over m. Okay, so we call this the negative reciprocal. So basically we take that gradient and then we find the inverse of it, so just do 1 over it, and then change the sign of it. Okay, so that's the negative reciprocal. To give you an example, if the gradient of a line is 4, the perpendicular gradient will be minus 1 over 4. Okay, see what we've done there? We've done the reciprocal, so the reciprocal of 4 is 1 over 4, and we've changed the sign of it to negative. If the gradient of the line was 1 over 5, we would find the reciprocal of this, so that'd be 5 over 1, which would just be 5, and then we'd change the sign, so that would be negative 5. And one more example, if we had minus 4 over 3 as our gradient, we would simply find the reciprocal, which would be minus 3 over 4, but then we'd have to change that negative to a positive, so we'd make it positive 3 over 4. So then what we're going to do is look at how we can find equation of parallel and perpendicular lines. In our first example from page 14, we're going to find the equation of a line that's parallel to y equals 2x minus 3, and it passes through the point 3, 7. So first thing to note is because we're looking at the equation line that's parallel to y equals 2x minus 3, we know it has to have the same gradient. And we know that the gradient of this line is just 2. Okay, it's already in the form y equals mx plus c. So we have a gradient of 2, so m equals 2, and it's going through this point 3, 7. So we've got a gradient and we've got a point on the line, so we can just go and do what we was doing in the last video and use our equation for the line. You can also, of course, use y equals mx plus c as well if you wish, and then substitute that 0.37, okay, whichever way you prefer to do this. So I substitute in y1 as 7, the gradient as 2, and x1 as 3. Expand the bracket, and then I just need to rearrange it in an appropriate form. So I'm just going to leave it in the form y equals mx plus c here. You can, of course, because you're not told a particular form to leave it in, you could also leave it in that form ax plus by plus c equals 0. The next example we're going to do is where we're going to find a perpendicular line. Okay, so you're told a line perpendicular to y equals 2x minus 3 passes through the point 5 minus 1. So this time we're going to give the equation of the line in the form ax plus by plus c equals 0. Now it's the same line again. Now we know the gradient of the line, so we know the gradient of y equals 2x minus 3 is 2. Okay, we already talked about that in the previous example. But we're not looking for a parallel line this time, we're looking for a perpendicular line. So if the gradient of the line y equals 2x minus 3 is 2, the perpendicular gradient is going to be the negative reciprocal. And that is just going to be minus 1 over 2. Okay, remember when we find the equation of the perpendicular, find the perpendicular gradient, we're going to do 1 over the gradient and then change the sign, okay, the negative reciprocal. So now we have a line that has a gradient of minus a half, and we know this point 5, 1 lies on the line. So we put it into our equation of the line, so y minus y1, so that's y minus minus 1 to make it y plus 1. The gradient is minus a half, and then we do x minus x1, so x minus 5. I'm going to multiply both sides by negative 2. What that does is that completely gets rid of that negative half there and just leaves you with x minus 5. If you wanted to do it in 2 stages where you multiply by 2 first, then multiply by negative 1, or you could just multiply by 2 and then expand the bracket out by -1. There's lots of different ways that you can get to the answer, whichever way works best for you. Now we're not quite done here. We need to leave it in this form ax plus by plus c equals 0. So we're going to add 2y to both sides, and we're going to add 2 to both sides, and we get the following answer. Note that I could have also rearranged the other way, so I could have actually minus the x from both sides and added the 5 to both sides, and we've got minus x minus 2y plus 3 equals 0 instead, which also would be an acceptable answer. Finally, we're going to look at an exam style question here. So this is in 2 parts. The first part, we're told the line L1 has the equation 3x plus 5y minus 2 equals 0, and we're going to find the gradient of L1. So let's do this part first. Now, this isn't in the form y equals mx plus c, so let's just write out the equation and rearrange it into the appropriate form so we can find the gradient. So I'm just adding 2 to both sides and taking 3x from both sides, and then I'm going to divide both sides by 5. Make sure you divide both terms on this right hand side by the 5. So the gradient is going to be the coefficient of x, the number in front of the x. So the gradient is just going to be minus 3 over 5. Okay, just 2 marks there, that question. Oh, sorry, I didn't mean to do that. Just 2 marks this question here. So that's all we need to do. So that's part A. Now looking at part B, you're told that the line L2 is perpendicular to L1 and it passes through the point 3, 1. So if the gradient of L1 is minus 3 over 5, the perpendicular gradient, remember to find the gradient, to find the perpendicular gradient, we need to use the negative reciprocal. So if the gradient is minus 3 over 5, the perpendicular gradient will be 5 over 3. Okay, we do 1 over it. Okay, the less technical way of saying that is flip it, essentially, and then change your sign. Okay, so we change the negative to a positive here. So now we're looking at a line that has a gradient of 5 over 3, and it passes through this point 3, 1. So substitute everything in. We've done quite a few examples of this now. And then I'm going to multiply both sides by 3. And then I'll expand that bracket out on the right hand side. Okay, if you want to do this in one step rather than 2, you absolutely can do. It's whatever you feel comfortable with. And this time we're asked for the form y equals mx plus c. So I need to make sure that it's in that form that we're being asked for. So I'm going to add 3 to both sides and then just simply divide both sides by 3 there for the final answer.